Hey guys, welcome. Yeah, so example 3 here, probably our final example on the mean value theorem, is I think the most interesting and the most fun. And here's what we have to do, which is show that this inequality is true. All right, now to start, note that our inequality is the same as this here. What have I done here? Not much really. All I've done is from these two terms here, I've factored out a negative, right? And so that way I could write this. Okay, and next I'm going to use the fact that addition commutes, and inside this parenthesis here, I'm going to lead with the cosine squared v. So if I do that, then I could write this is what I'm saying. Now, note that cosine squared x minus sine squared x is cosine 2x. So we can write this as cosine 2a, and we can write this as cosine 2b. So if we do that, we see that our inequality can transform to this. Now, after this, what we're going to do is recognize that the absolute value of a minus b is the same as the absolute value of b minus a. That recognition will allow us to write our inequality like this, which is we could swap these two and then swap these two and where they appear, and so we could write this here. Yeah, okay, what should we do next? I think we should divide by the absolute value of b minus a on both sides of this inequality. All right, now we're dividing by something positive, so we don't need to change the direction of the inequality, right? But in going from here to here, I could have showed one extra step, which is showing that the absolute value of a quotient is the same as the absolute value of the numerator divided by the absolute value of the denominator, right? I've exploited that, right? Okay, cool. Now, once here, look at the left side. Why did I want this here? Well, I wanted it because, look at it. If we claim that the function f is cosine 2x, then I've got f of b minus f of a divided by b minus a. Familiar? Yeah, that's from the mean value theorem, right? Okay, so we let f equal cosine 2x on the interval ab, on the closed interval ab. Clearly, cosine is continuous on the closed interval ab, any closed interval ab we choose, and it's differentiable on the open interval ab, right? We know that about cosine 2x, and therefore what? By the mean value theorem, there must be a c in ab, so that what? So that f of b minus f of a divided by b minus a is equal to f prime c. All right, but what is f prime? F prime is negative sine 2x times 2, and so it's negative 2 sine 2x. So f prime c is going to be negative 2 sine 2c. And notice that negative 2 sine 2c is lesser or equal to the absolute value of negative 2 sine 2c. That is, this here is lesser or equal to f prime of c, right? Which means it's, well, f prime of c, with an absolute value, is equal to this, right? But then we know sine 2c is bounded by negative 1 and 1, so the absolute value of sine 2c is bounded by 0 and 1, so its upper bound is 1, and so the upper bound for the absolute value of negative 2 sine 2c must be 2, and therefore f prime of c is lesser or equal to 2 by these transitions, right? Okay, so then we're saying that this here is lesser or equal to 2. All right, so then we're practically done with what's required, because that means then if I put absolute value bars around this guy, it's going to be lesser. Well, first of all, absolute value around this means absolute value around this, and we know that absolute value of f prime of c is lesser or equal to 2, and therefore we see that this follows, and then we don't need this bridge right here, and so we could just jump to this, right? But then this means that by the property that allowed me to go from here to here, right? But going in reverse, I could be like, the absolute value of a quotient is the absolute value of the numerator divided by the absolute value of the denominator. And that's all I've done in going from here to here, right? And it's obvious what I should do next. I'm going to multiply both sides of this inequality by absolute value b minus a. And when I do, I get this. But wait, this here is the same as this, so long as we use the cosine double angle formula and replace these guys, right? Okay, cool. I hope you enjoyed this, and yeah, this is it for the mean value theorem, but lots more math videos to come, and keep watching. Take care.